What form is that equation in? Which one? Standard. So guys, notice I'm asking you that every time because we do different things with each form. And we know information from each form differently. What does y mean? Up there, y equals, what does y mean? Yep. And then our variable says x. What is it really, though? Like, if we wrote this as a better equation, what should we make x? Yeah, time. Probably t, right? Okay. Good to identify your variables so you know what's going on. Well, standard form, we're looking for the maximum height. How do we find that? Good. So the max is the vertex. So negative 32 over 2 times negative 16. So what label would I put on the 1? 1 what? Yeah, that's 1 second. So it happens 1 second after we toss the pebble. And then it asks for the height though. So what do we do with that 1? Plug it in, good. So plug it. I don't like that they use y. I would have used h for height, but we'll use y of 1. So negative 16 times 1 squared plus 32 times 1 plus 80. So this is, these two do what? Well, this is negative 16 plus 32. So, what is that, 64 feet? Okay. What?
I got 96. I got 96.
It should be negative 16.
Yeah, but what about the 32? Yeah.
You're right. What is wrong with me?
Oh.
Good job.
See what happens when you do mental math? Yeah.
See what happens what?
See what happens when you do mental math?
Anyway. What is the 80 in the context of the problem? And don't say y-intercept, that's math. What is the 80 in the context of this situation? How high was that? But yeah, that's where we threw it from. So standing 80 feet above the ground. Good. How'd that go for you? Better than me, hopefully. Okay, good. And what was the little tiny detail that told us that it had a maximum? Not the wording, but in the equation. Negative a value. Good. How'd those problems go yesterday? These ones. Let's go ahead and check them. So pull that out. Let's check. Very good. It is the time of the week to be time. Okay, so first one, what form is this? Standard. So find the vertex the same way we just did. Start with the vertex. Y-intercept is just negative 7, but remember it's a point, so put 0, comma, negative 7. Axis of symmetry goes right through the x-coordinate of the vertex, so that's at 4. How do we find or solve for the zeros in standard form? Yeah, star factor. Or, if it doesn't do that, we'll use the quadratic formula. Anyway, your 2 zeros should be 1 and 7. And then I would do all that stuff and do the graph before I do the domain of range and intervals of increase and decrease for sure. Okay. How'd that one go overall?
Good.
Good. Why is there a bracket right here?
It can.
Yeah, it goes up through 9 and then comes back down, so it can be 9. And we've talked about leaving all the other ones just as parentheses for this. How about factored form? This is technically missing something. What is it missing? f of x. We really should have an equation independent variable, right? Should say f of x out front. All right, next one. What form is that one? Factored or intercept form. Good. How do you find the vertex in factored or intercept form? Right.
You get the average, right?
Yeah. Yep. So the two zeros are 6 and -1. So that makes 5 when we add them. 6 plus -1 is 5 divided by 2. So there's our 2.5. And then definitely plug 2.5 in with your calculator to get the y coordinate. Any questions on just the vertex? Okay. Y-intercept, how do you get it from this intercept form? Yep. Just like always, we'll make the two x's be 0. So we'll get -6 times 1 times 3. So -18. And a is, what is a in this problem? It's 3. Yeah. So a is positive. So it's a vertical stretch, opens up, all those things that we know from that. And zeros are easy in this form. So once you have it graphed, hopefully everything went well. How do you convert from this form to standard form? We haven't talked about that. We'll put a few little notes about it today. Yeah, from factored to standard. How do you do that? So multiply it out. I would think of it as putting brackets in front of the 3 and do the inside and then distribute the 3. That's how this one was shown. So multiply the 2 parentheses and then distribute the 3. That's the safer way to do this. Any questions on that one? By the way, I did see this one is almost like that. Actually, it's a little bit too much like that. But parabolas are rounded. So if you're drawing yours as a v, I will mark that wrong. Because that's a different kind of function, which is what? Anybody remember?
Absolute value.
That's an absolute value parent function. So don't make these a v. They need to be round. This one is roundish, but it's too much of a v. That one was okay if you connected it. That one's kind of round. All right. What form? That's vertex form. So the vertex should be just a quick read. 2, 3. How do you find the y-intercept in vertex form? Y-intercept in vertex form? Set x to 0. Then be careful with order of operations. What is -2 squared? That's where you need to start. It's 4, positive 4. And then 4 times 4/3 is 16/3, but negative now. And then this is 9/3, so we get -7/3. Okay? Which is the same as 2.33. How do you find the max in vertex form? Max or min? It's just the vertex, right? So it's quick and easy. All right. Notice this one didn't have you find the zeros. How would you? Nope. All right, so everybody do this, please. Put it on the back side of your paper, I guess. This, for some reason, this tends to be a thing that students struggle with and really shouldn't be. So please try to get there today. How do you solve for zeros with vertex form? We wrote specifically about this, both as an example and in just the description of your notes. So if you don't know, please look. I'll give you 10 seconds. How do you solve for zeros, or how do you solve when you're in vertex form? If you don't know, look it up in your notes. If you don't know it, if it's not locked in your head, then look it up. If you don't know where stuff is in your notes, it means you're not looking at them very often, which is a big deal. You're looking right here first, methods to solve, and oh hey, if it's in vertex form, we're going to square root. So you could look there. You could also look in your example section and solving in vertex form. Either place is fine. So with that said, we're going to set this equal to 0, and then we want to get this by itself. So get the squared thing by itself. So we need to subtract 3. Now what? How do you get rid of the next thing? Okay, we could divide by 4/3. We could multiply by negative 3/4. Right, this says negative 4/3 times our group being squared. So dividing is fine. The only thing with this is I think a lot of people don't know how to divide fractions. Right? So what is negative 3 divided by negative 4/3? Well, what happens with the negative signs? The negatives cancel, and this becomes 9/4. Okay? If you did it as a decimal, what is the decimal for 9/4?
2.25.
Yes, 2.25. Okay, next step is to do what? Square root. Left side gets to x minus 2, it just cancels the squared. How do you square a fraction? Square root a fraction? Yeah, we can just do the square root of 9 over the square root of 4, which we should know both of those. What are those? 3 over 2. And don't forget your plus or minus. So add or subtract. So that means to finish off, we'll add 2. And we have two options. We need to do x equals positive 3/2 plus 2, and x equals negative 3/2 plus 2. Right? Well, x is 7/2, or 3.5. Over here, x is 1/2, or 0.5. So you need to make sure you listen to this. If this is a struggle for you, you definitely need to address that today. Okay? Solving in vertex form should be an easy thing to do by now. Just get the parentheses by themselves. We had to subtract and then divide and then square root. It's pretty. Those 3 steps are pretty common. Any questions on it? Okay, let's go check our graph and see how, since it didn't ask for those, let's go check our graph. So roughly, it should have gone a little bit further to the left for the 1/2, and then 3.5, that one's pretty close. It's pretty good. That, basically what we just did, makes up the first page of your, first page and a half, because it takes a little more room, of your quiz. No graphing calculator. So how do you feel right now about that? Just give me a thumb somewhere. If this had been your quiz, it will look very similar to this. Okay? So just think, where is your thumb? If it's up here, you're probably safe. If it's not, then we need to address that. So maybe come get some help. All right, 2 things to talk about before we're over that completely, like ready for that quiz. It's like what we did on the warm-up. I think we're pretty much ready for this overall. Anybody ever been to a place like the picture? Like Top Shot, I think they call it, over in Denver? Top Golf. Top Shot is here. Was it fun? All right, well, again, it says this is a similar situation to what we just did. comparing it to the warm-up, we stood on top of something and tossed the pebble, and we asked about the maximum. What does this one ask about? Yeah, when, first of all, that's a time. When does the ball hit the ground? So this is a different question. We could have asked that same thing for the pebble, but we didn't care about that. We cared about the max height. How do you know when this hits the ground? Go ahead, Henry. Okay. So start thinking about how these look when we graph them. And it's kind of started here. So if we think of this as our starting point, it's going to graph as a parabola and come down and hit. And so the ground is when h equals what? Yeah. So we are basically solving for the zeros. That's all, right? Okay. Go ahead and do that with this one. I'll give you just maybe 2. So 2 questions. How many of you wrote set this equal to 0? Only 1? Well, I'm saying how many of you put the equals 0 on there? Okay. You should do that, right? That tells us what we're solving for. Also, what if the question didn't say when does it hit the ground? What if it said, like these kind of places sometimes have targets you're supposed to hit? What if there was a target set up right here that was, let's say, I don't know, 15 feet off the ground? If you don't get in the habit of writing an equation, what's going to happen? You're going to solve probably for the zeros, and if we're trying to hit a target 15 feet off the ground, we need to say 15 here instead, right? So make sure you're writing the situation as an equation and not just kind of getting in a habit of doing whatever you want. Be careful. Okay, this time it's 0, so make it say 0. Don't forget to pull out your GCF. If I pull out the negative 16, that keeps x squared positive, which is definitely what we want. But then that makes this x negative, and the 32, which becomes 2, also negative. So be careful, just that basic division step. Are there factors of negative 2 that add to negative 1? Yep, so it's x minus 2 and x plus 1. If you need the star, we're doing this. So factors of negative 2 that add up to negative 1. Okay? What else? What else do we do from here? This is factored form now, right?
Yeah.
Okay. Guys, some people, I don't really know why. I think maybe they just get in a hurry. Maybe they don't actually get what's going on. But some people just say negative 2 and positive 1 at this point. Is that accurate? No, because we need to set these equal to 0. And this is when the sign flips. So we get 2 of these. Why is there a negative answer? And like this is an in context, I hit the ball problem. Why is there a time that's negative?
Because that's bad for negative.
Technically. So look, if we just purely looked, if we took away the golf and just looked at this as a parabola, that's that negative 1. That's the other x-intercept for this parabola. Okay? In the context, it doesn't start until here, so we are only considering time 2 seconds is when it hits the ground.
Is that when the fake numbers come in?
No. These are both real numbers. The fake numbers will be when we try to square root a negative. Okay, take a mental note of this. Very often, these kind of problems have a negative time because we're launching or hitting or kicking off of something. So it raises that y-intercept. And so that other root is after, well, technically before the y-axis. And those times are nonsense in these contexts, right? It's like before the thing even started. Okay? What kind of situation, think, there's a bunch of you guys are athletes. What kind of situation would we actually start from the ground? Something that we're, huh?
Like a sport?
Yeah. Soccer. So a soccer kick would start from the ground. What else? A football kickoff. I mean, technically it's on a tee it's basically the ground, but, right, a football kickoff. You play volleyball. Would a volleyball serve be this? No, because even though we are not on something, the ball is starting from up here. So that would look, instead of this way, like this. So it's actually starting, and we would have another time that's negative. So if we said when would that hit the ground, you're going to have a negative and a positive. You only need the positive answer. Make sense? So lots of things. I guess golf, you hit off the ground, so that would be another one that's just at 0. Grab your notes. Let's go write a few of these things down. I don't know if in context means something to you, but put stories there if that helps.
Stuff. Sorry.
Scenarios, you could say scenarios too. I think, have this already, but I want it all together. So if it says, I'll just do it this way. If it says max or min, what do we solve? Like, what are we looking for?
Or wait.
The vertex, okay? Now, be careful, because sometimes it might ask for the time that it takes to get to the vertex. Sometimes like our warm-up, it might ask for the maximum height or minimum value or something at the vertex. So find the vertex, and then carefully choose either the x or y value, depending on the problem. So read carefully. Let's add, actually, I just thought of this. This might come up, so I just want to give you this reminder. The vertex is halfway, or average, halfway between the x-intercepts. So there might be a scenario when that's how you could find the vertex. If you know when it hits the ground and when it started, you might be able to just say, hey, I know the vertex is right in the middle of those two times. Okay, other versions of this. On the ground, means the height is 0. So set equation equal 0 and solve for the. Do you guys tend to, in your head, call them zeros or x-intercepts? Just curious. One more thing in here. Most of these will be height kind of problems, but it could be some like a monetary value if we're doing some money situation. So if the height or value is equal to something other than 0, what do we do? Like the golf problem, if we said, hey, when will that hit a 15-foot high target? So, yeah. Then what? Equals 15. How do you solve? Can we leave that 15 over there? Okay. No, we can't. So then get the equation equal to 0 before solving. We can do an example of that after you're done writing. The height of a drone in meters above its launching platform. So we're launching off, it's kind of hard to see, but this is some structure we're launching it off of. And it's 5 meters tall. And then it gives us this equation, which I'll write for you in the example. Okay, so we're dealing with time and height again, even though our variables are just x and y. So it says the drone leaves the launch pad, flies down into the canyon, and then it flies back up again. So who cares about that? After how many seconds will the drone be at ground level? After how many seconds will the drone come back to the height of its platform? Okay, so think about what this thing has done. It's doing this. And we have 2 questions. When is it 0? When is it 5? That's really the 2 things we're looking for. Okay, everybody clear on what we're asking? Okay. And also, why is it okay for this parabola to open up instead of down? Say it again. Okay, he is going down. Why is that an okay situation? Like pretty much all of our problems have been upside down parabolas and we're looking for the max or something. So what's different about this? Physics-wise. What? Gravity works the same on both situations.
It's possible for it to go down.
Yes. So it is possible to go down because it has a canyon, which is kind of what you said too, I think, right? So here's what I'm thinking. It's because this is a powered object, meaning it flies, right? It's not just drifting through the air by gravity. It's actually got motors that helps go wherever it wants. Make sense? So this is not the same kind of problem technically as what we've been doing. So you shouldn't see things like the -16. Because it has engines to make it run. Alright, help me remember this. 0.1x squared minus 1.5x plus 5. I'll probably have to switch back. Hopefully. So we'll call this powered flight. to distinguish between this and what we call projectile motion, which is everything else. Tossing a ball, kicking a ball. Those just go by until their gravity pulls them to the ground. This has power of its own. I'm going to change the variables just a bit so that they make more sense in context. So 0.1 t squared, and let's go check that, minus 1.5 t plus 5. Okay. So we'll ask, when will it reach ground level? When will it reach, and it said 5, we could say anything else. Keep come back up, keep going up. Or maybe we care about some other one. 15 meters. Okay, I'm just changing it slightly. Actually, let's leave it at 5. You can erase that one. Just leave it at 5. If you want, I think it's a good idea to do this. Powered flight. So we're starting at 5, coming down. We could even come down below if we want. Just to remind yourself that this has a different direction that it's opening, the parabola does. Henry, are you good on this? Write it down. Alright, well, what does on the ground mean? We just wrote it. Our height is 0. Good. Height equals 0. So 0.1 t squared minus 1.5 t plus 5 equals 0. How are you going to solve that? Because it's not going to be factorable. Well, I shouldn't say it that way. It doesn't look factorable. So how are you going to solve it? Well, what if this was 10, 15, and 50? In other words, if we multiplied everything by 10. Is that factorable? I don't know. I mean, I'm asking you. So 10 times 5, sorry, 10 times 50 would be 500, and then we're trying to make 15. So are there factors of 15, or excuse me, of 500 that make 15?
Wouldn't it just be 50 if you multiply by 10? Because that would just be a 1.
Okay, so if we multiply it, here's what I'm thinking. Oh, you know what? Yeah. This is 50. I had one extra power of 10 in it. That's what you were saying, right? Good job, good catch. Are there factors of 50 that add up to 15? Yes, what are they? 10 and 5. So this is factorable in its current form, but we just have to put decimals in there. Okay? So that's good to know. Let's factor it. So 0.1 times 0.5 is 0.5, and then negative 1.5. And A is 0.1. Okay, is this too small? Bless you, whoever's listening now. So anyway, are there factors of? Hold on, I told you that it's factorable, but I didn't look closely at the sign. So why should I have said that this isn't factorable? I'm pointing to it right there. So the 10 and the 5 won't be able to make this. Will that work? You guys help me out. I'm saying this. If we yeah, it should work. All right, here's what I think we should think through. It's top left button y equals. Okay, 0.1, and you have to do x's even though we wrote t's. 0.1 x squared minus 1.5 x plus 5. So there's our parabola. Everybody good there? Hit graph. And depending how your window is set, you may or may not see it at all, or you might not see this thing. So if you want the standard zoom window so we all have the same picture, hit the zoom button, top middle, and hit 6. You can just type 6. Okay, so you'll all have it looking similar to that. Everybody see what I'm seeing? Okay. Now this calculator also, if you hit zoom, an arrow down to zoom fit. Hello. Come on in. Zoom fit tries to fit the window to the function that we've plugged in, but it doesn't always do a great job. So let's try it this time. So zoom 0. And so I personally think that's about the same as it was. Okay. All right. The first question says, where does this have a 0 level? So above the trace button, do you see how it says calc? Second calc. Okay? Look at choice 2. What does it say?
0.
That's what we want. Well, one of the things we want, right? So go ahead and hit 2. Everybody with me?
Yeah.
Okay. Holler out if I get ahead of you.
Wait, why does it say wait, you're out?
I'm going to tell you. Okay. Look here for a second. I need to point to something. Okay. Do you agree the 0 is roughly here?
Yeah.
So what this calculator has to have you tell it is the two sides that it wants you to look between. So the left bound means you've just got to be to the left of the 0. You don't have to be on a specific value. As long as your little cursor is left of the 0, you're fine. So mine is, I'm going to hit enter. Enter. Okay, and then the right bound means, hey, I need the right boundary of where I'm looking. So we need to arrow to the right until you're past that 0. Okay? And it does, again, it doesn't have to be on a certain value, just over there somewhere beyond the 0. Beyond where the 0 is. Hit enter again. It will always ask you for a guess. And here you can just hit enter. You don't have to put in something new. Okay? So 0, that 0 is at x equals 5, which means what? In our story. What does it mean? 5 seconds, right? Yep. All right. So we know that one of these is at 5 seconds. This is going to swing back up and have another 0 over here. So let's do that whole thing again. What were the keystrokes to get there? Second trace. Second trace. 2. Left bound. We're okay for the left bound because we're left of the next 0. So hit enter. And then just arrow off over there until you see this y value go above, like go to positive. So there. Well, actually I just hit it. That just happened to happen in this case. But if I keep going, I'm beyond that. Okay? So my right bound, and it's going to happen at 10. Are you asking about yours?
Yeah.
We'll have to look at it specifically. Yeah. So our other 0 comes back up at 10 seconds. All right, let me ask you this. Everybody clear on where we got those? And by the way, that tells us that this is factorable. So the 2 here would be x, well not x, but we would write minus 10 and minus 5. So x, we're doing t minus 10, t minus 5. Okay? Next question. When will it reach 5 meters? Well, where did it start? If you remember the problem that we started at. So it should have a time at 0, right? 0 seconds. It started at 5 meters. Right here. So 0 seconds. This is 5 seconds. 10 seconds. What do we know about this time right here? What should we expect our answer to look like if we're predicting answers? What should it be, roughly? Yeah, it should be bigger than 10, right? So how are you going to figure that out with your calculator? Because this one won't be factorable regardless of what we had started with. Well, grab your calculator one more time. Go to y equals. This time, leave your parabola in there. And this time, just put your y2 at equals 5. That's going to make a straight horizontal line that we can look for this to intersect. Everybody with me? Okay. Go graph it just so you can see what it looks like. There's our horizontal line. This parabola will swing back up. Our drone will swing back up and intersect that line. Okay? I personally am frustrated that I can't see it. Anybody have an idea of how we could move the window so we could see that point? Because it sure would be nice. Okay? You could try zooming out. She said zoom 3. Okay? You can kind of see it, but it's not that good. Does everybody agree? And I tend to not use the zoom keys because of that. So I'm going to go back to zoom standard. Here's the better option. Window allows you to completely customize where you're looking on this picture. So grab or hit window. Do you see how right now it's defaulting to only go out 10? What did we predict would be our value for that time? Yeah, like maybe 15, right? So change that to maybe like a 20. We should get to the other side of it with 20. There we go. Yeah, press graph again. Okay. So I'm going to give you a hint. It's to find that point, we're looking for this point right here where the drone comes back to 5 meters. It's under the calculate menu. So go in there and see if you can figure out which one it's going to be. I just want you to try to critically think about this. Are we solving for a 0 now? No. So in that menu, which one do you think makes sense? I heard it. Intersect. Good. Awesome. Because we're looking for the intersection between our parabola and that line 5. Okay? So you can either hit 5 or arrow to 5. Intersect. This time the questions are similar. It wants to know is the first thing it wants you to check your parabola? Well, yeah, it is, of course. So yes. Is the second curve the line? Yes, it's called a curve even if it's not a curvy thing. All right. Guess. Do you see how it happens two different places? This is where we launched from. So we want our cursor to be closer to the other one. You don't have to try to go be right on it, but it's basically telling the calculator, look in this neighborhood. Make sense? Hit enter. And there's our intersection. What do you notice? You guys are right on, huh? Your gut told you what time this is going to happen? There's our 15. Okay? So t equals 15 on calculator. Okay. Before we move on, I want you to try this once on your own. Okay? So we'll think of the drone scenario again, but let's say our height is a different function. So clear your calculator. Let's say this time we're starting from a 20-meter platform. And we want to know if this continues, how long will it take time to h equals, let's do 40 meters. So it's going to launch, come down, and then shoot up to 40 meters. How long will that take? And so this one, if you notice, doesn't cross. It doesn't cross the x-axis. Is that a problem? Like for this application, is it a problem? Okay. I'll probably, yeah, so if your window looks like that, on these calculators, I really don't like the zoom features at all. Other than zoom standard, so zoom 6, puts it back to the normal window, like if you first worked on this calculator. Does everybody see I need to take this window, that parabola is sitting up here, so I need to move my window up and over so it's more centered. That's how you think about zooming around on these. So if you hit window, I need to move my Y, the top of my window, I need to move that up. So I can make this 30 or 40. I'll just say 30. That shifted my window up. And then I need to move my window to the right. So that's X direction. So move that maybe to 30 as well. And now when we look at this, it's gone from here up and over, and now we're centered right on our graph. The window keys are way more effective than the zoom keys, just so you know. Okay? All right, so we want to find that point of intersection. So calculate second trace, and we're looking at 5. Remember, this is just asking, the calculator needs to know, is this the equation you want me to use? So when it says curve, it's saying, is this the one that I'm looking for? Yes. So just hit enter on that one, and then make sure you're telling it to look for this right point of intersection. And it tells you it happens at 15 and 20. Okay? So time equals 15 seconds. Height equals 20 meters. Is that something different than you got? Oh, it's because I put something. I put 20, not 40. Let me just switch that real quick. Yeah, okay, that's why. So I need to raise my window Y max to 50. There we go. Anyway, same process. But let me get you a correct response here. So when will it reach 40 meters? At 20 seconds. Okay, what I've just shown you, number 1, is an example on how to solve in context and use your calculator to check. Okay. Any questions on that? Okay. Here's what I just told you. This drone problem, you now could solve and check with your calculator. Okay? That. Also, our warm-up problem, or this one, you could punch this in. This one asks, when does it hit the ground? So in your calculator, are you doing 0 or intersection? 0. So you could go check your solutions with your calculator with that kind of problem. Okay, warm up the pebble toss. You could enter this and go find the vertex. It's probably not going to be super accurate compared to just solving for it, but you do have that option. Okay, speaking of the quiz, I will not accept just an answer. I need work to back it up. Okay, so at least get it set up to that point. Any questions on any of this stuff? Yeah. My last question is this. Do you want, in terms of converting between like factored form to standard or vertex form to standard, do you need to know